Welcome back everyone. This video is a direct follow-up to last month's update video, so if you haven't seen it, go check it out here for context. And quick recap, in order to do all the scenes on this city model, we had to come up with a way to automatically switch between 3 different lighting situations. So this meant switching on and off various studio lights as well as the tiny LEDs which are incorporated directly into the model, and also switching the image which is displayed on the TV monitor behind it. So for all the direct lighting controls, DragonFrame has this inbuilt DMX control window, which is very convenient and easy to use, but I had to buy the proper equipment and cobble together some custom electronics. Okay, so I made this beautiful abomination of electronics here. It's basically a piece of board where I screwed on various things. And what it does is it takes a DMX lighting control signal from this DragonFrame DMX interface, which goes directly here into the blue section, which is a whole bunch of relays which I can use to switch all kinds of things on and off. And 2 of the things I can switch are these 2 power outlets here, where I can directly plug in my studio lamps. For now I can only switch them on and off with this board, but that's enough for now. Brightness control is not that necessary for the moment. And I also incorporated a direct power connection onto the board, which powers the 2 outlets, and a little power supply for the relays and another one for that contraption here. So this section is a stack of an Arduino and DMX shield and a custom PCB on top, which I machined myself on my mill manually and cobbled it together from spare parts basically. This enables me to also control the brightness of my tiny lights from DragonFrame. First LEDs, which are easy to control in brightness just by switching them on and off very quickly. That's called pulse width modulation, and the Arduino already can do it by itself. More difficult is classic light bulbs, because they require an analog voltage. And usually I just use these power supplies, but I discovered that one of my power supply has a remote control input where you're supposed to hook up a little potentiometer. And of course, instead of a potentiometer, I can also hook up a digital analog converter, and that's what I did right here. So now I can take the digital signals from DragonFrame and turn them into an analog voltage to drive real light bulbs and control them in brightness via DMX, which I think is super cool. So that part was not strictly necessary for the shoot we were doing this month, but it will come very much in handy when we're doing the animations in the Scrapyard with the jellyfish creature which has this light bulb inside, which will glow up with every of the pulsing movements of the creature. And there are also some other occasions. Generally I really like to use classic light bulbs, so now I'm really glad I found a way to control them with the DragonFrame lighting controls. Yeah, I really enjoyed doing a bit of electronics again, and it went really well, I think. However, controlling the monitor was far less straightforward, as there are no already existing solutions as far as I know. So for this I reached out to Marcus, who is one of my Patreon supporters who has offered his help with software development in the past, and so this was the opportunity now. Together we found out that DragonFrame has various APIs which we could use to interface with software directly, which is very convenient. And the one we used is the TCP serial interface. It runs over the local network, and it basically tells us everything which is happening in DragonFrame. Like every time a frame is taken, which frame number and which exposure, etc. And so that was the information we needed. Next up was how to get this information on screen in terms of different images for different exposures. Marcus had the genius idea of just running a local web server, which creates a web page I could open in the browser, which just displays the image. So I think this was a really good approach because it didn't require any graphical user interface programming. And Marcus implemented it, and now I just have to start this Python script and prepare some images which have the same names as the exposures in DragonFrame. And then basically I just connect DragonFrame with the server and open the web page on my laptop, which is connected to the monitor, and then run it in full screen, and I just see the images for each exposure, and it updates automatically every time a frame or exposure in this case is taken. So the system worked perfectly on the first try and it was a pleasure to use. And also I really enjoyed this collaboration. It just made things so much easier and I can't thank you enough, Marcus. Thanks a lot. In addition to that, for everyone else who's also doing stop motion and might want to use a monitor as background, the entire project is open source and available on GitHub, free to use for everyone. So in case you want to use a monitor for different exposure lightings as I did, or also just as virtual background to replace a blue screen altogether, that's a very nice idea, I think, and the little Python script is very easy to use, and there will also be some more features added soon, I heard. So please check the project out on GitHub, links in the description. It would be really cool if other people could also benefit from this little idea. Now we were nearly ready for shooting, but there was one more thing to automate, and that was the rotation of the set. There are a couple of shots where the camera is supposed to move around it, but instead of moving the camera on a curved track, which would be very difficult, it's much easier to just rotate the entire model in this case. It's conveniently set up in my rotary table, but moving this frame by frame would also be a lot of manual work. And as I already have this stepper motor driver from Noxon, it was fairly easy to cobble together something to drive it with a motor. And this little belt drives we were using here came actually from the gearbox of my lathe, because that was around at the time. Then in the second half of the month, Maurice and I did a whole lot of shots with this model. And we just set everything up, which took a couple of hours, and then pressed start and off it went like magic. So here you can see the three exposures from one of the scenes next to each other. Left is the blue screen exposure, then in the center is the base basically with the normal lighting conditions where you can see the rock and all the details. And on the right side is the lighting exposure where you can only see the tiny light dots. And that's how they will be combined into a final image eventually. Of course, this is only a very early mock-up. It will be much more sophisticated later, but that's the idea. So this month we concluded the shooting of this particular model, but it's not the end of it, because in the movie this column is slowly shrinking and getting thinner and more fragile. And we're shooting it in reverse, so what you're seeing here is actually the thinnest stage of the city. And next month we're going to take it apart, add some more plaster and put on the details again, and then do some more shots with a slightly thicker version of it. So yeah, that's the plan for next month, and fingers crossed, also something I'm quite nervous about it if it will work as planned. We will see. I also finally had the time to make one other Scrapyard creature, but it's a very unspectacular one. It's a leg. Just a leg, nothing else. Yes, and a very scrappy one indeed. Let me explain. So the Scrapyard has a lot of broken robots and old machines which still have a bit of life left in them. And so this leg is one of them, and it will jump around very happy and be very scrappy. Haha. So yeah, this was surprisingly difficult for me, because nowadays I'm used to this very clean, precise workflow, which is completely unsuitable if you want to build scrap. And so I really try to make it in the same way as I did the very early robots, just with basic hand tools and eyeball everything and don't clean up the soldering joints and everything and just leave it as it is. And I think it works well as scrap. But of course the joints are much smoother than on my early builds. It should still be a pleasure to animate, I hope. And that's also something I'm really looking forward to. I just enjoy these abstract, a bit more funny animations much more than this realistic human movements, for example. So there will be a whole bunch of Scrapyard creatures of this kind as well to look forward to. But for now, let's talk about another kind of robot, this month's robot kits. Okay, so this month you're getting 2 little sub-assemblies with a bunch of screws. And so these parts, of course, are a bit easier than last month, but especially this gear gave me a lot of headache when designing all the parts around it. First we have this little block with a screw right through its center, and the screw has a special little dimple on its end, and it's already inside its thread because the thread is slightly underside, so the screw basically is already a bit tight, but sometimes they tended to jam up, so I thought it's safe if I just screw them in to check if it works, and you will have to do some fine adjustments on that screw later anyways. Then about this gear, that's a miter gear, meaning that its teeth are on its face rather than on the perimeter. And these kinds of gears are rather hard to come by. I used one in the original character, so of course I had to make it very similar on this kit. But I couldn't find any supplier of those gears, and I only had 2 or 3 of them originally. And they are basically impossible to buy, especially if you need a special pitch of the teeth. And eventually I found someone on eBay who sold them, but in the United States. So I bought them there, and then I discovered, oh no, the little screw here and the inside hole diameter is in imperial units now, and so I also had to buy some 1/8 inch rods. And it was quite difficult to get all these materials, but obviously it worked eventually. And then I have 2 6mm screws and 2 slightly shorter 5mm screws for you, and 2 very long screws with a special beveled edge, which I machined on my lathe. And those are to replace those 2 normal screws, which we discovered last month interfere with the housing. So before we do anything else, let's change these 2 screws on the already existing torso assembly. Should be fairly trivial, I already did it here. If you're not sure about it, then just check out the assembly instructions from February again. And after you did it, this assembly should fit inside the housing quite well and don't interfere with the sheet metal anymore. So the holes on the sides should be able to line up now. Okay, so the first step of the real assembly now will be to add this little block with the screw on the back side of the torso assembly with the screw head pointing downwards like this, and use the 2 6mm screws to screw it in place, just like this. Oops. So next we're taking the casing with the shoulder and neck piece, and before we can insert the miter gear, make sure to loosen those screws on the top side here again, so that the neck can slightly wiggle around. And with that loose, it should be fairly easy to insert that gear from below like this, and it should be freely turning. Now when we carefully tighten those screws up here again, at some point I discovered that they will jam the gear. So probably the pieces are just not precise enough. But carefully tighten them until you reach the point where you feel that the gear is jamming. I think maybe a bit more. Like this feels about fine. If you want to use the puppet for stop motion, it can actually be helpful to tighten it a bit more so the head will stay in place when you turn it. But if you want to use it as a toy, then probably it's nicer if the head is freely turning. Okay, so now we should be able to insert that gear assembly inside the housing. Can be a bit difficult to get in, but eventually it snaps in place, and then it pushes all the way up to the miter gear. And when that's the case, the gear usually jams a bit or doesn't want to rotate freely anymore. So we actually need a tiny bit of gap between the gears. And so we carefully pull that down again. And that's the reason those holes on the sides of the casing are elongated. So you will be able to adjust the position like up and down for about a millimeter. And then we take the two 5mm screws and insert them at the sides like this, so they're holding the gear assembly in place. Don't tighten them yet, because we want to do some fine adjusts probably. Just get them in for now. And then you can wiggle the thing from side to side to adjust the perfect distance between the gears. So you don't want it to be jamming at any place, but also the gears should have quite a bit of engagement, not like barely touching or anything. And also those miter gears are sadly not of that high quality, so some of them tend to wiggle a bit, and so you actually need a bit of free play so they can turn all around without jamming at any place. So in order to get it quite right, it might require a bit of back and forth, loosening and tightening those screws again and wiggling it up and down until you're happy. But eventually that thing should be freely turning without jamming at any place and just feeling quite nice. And that's how I originally designed it. But then I realized when the thing is upright like this and the head is on top of the axis and pressing down on the miter gear, like if you press it down like this, it tends to jam with those gears, and that's not very nice. Like the gear needs to be pulled up so there's a slight distance between the gears, otherwise they're jamming. So that's the reason I basically in the last minute added this block with the adjustment screw, and this screw acts as a bearing for the gear. That's the reason the axis had a little cone on the end that will mesh with the little dimple on the screw. And now when you slowly tighten the screw, not with any force, just very slowly, and double check the wiggling space of the miter gear, at some point it should start to touch the cone, and you basically adjust it until there's just a tiny bit of free play, but not that much that it jams the gear again. Just like this, and now it can't be pushed down to a point where it jams with the gears. Like it's basically free turning all the way. Maybe a bit more. That was a bit too much. Now it's jamming. Also a bit of back and forth with the adjustments, but yeah, that feels about right. Just a tiny bit of free play, and it's kept at a nice distance with the main gear. So a lot of tiny adjustments this month. So maybe this month is more challenging for you than it was for me. But next month there will be some more complicated parts again, I guess. And I hope this works for you. It's definitely one of the parts where I was really nervous about if everything will mesh correctly, because all those gear dimensions and getting the distances right is already difficult. But if you're at a right angle with one of those miter gears which have not a very optimal geometry anyways, it can be really nerve-wracking. And I'm glad it worked on my piece here, and I really hoped it also will work on yours. Also, if it's not completely freely turning, it's not that big of a deal, because eventually we'll have the head, which is much more to grab onto than this little rod. But you can also turn it from below here, and that way you should be able to turn it completely around without it locking up at any place. So good luck with that. I hope you will be able to adjust everything precisely, and have fun. Okay, I really hope this works out for you. Let me know if you encounter any troubles as usual, and I promise next month will be a bit more straightforward again. Yeah, I think this concludes this month's update. There are a lot of things to look forward to next month, and if you enjoyed the video so far, maybe consider subscribing, hit the like button, or support my work on Patreon. It's greatly appreciated. So thanks a lot everyone, and see you next month again. Bye bye.